Now you have seen the first two sums. Now we see the next sum is the eighth. It's related to the modulus of the function. Please see. 8. Fx is mod of x upon x. X is not equal to 0 and equal to 0 when x is equal to 0. You know that if x greater than 0, mod x is plus x, and x less than 0, mod of x is what? Minus x. So your function will also change. See here, if I take x greater than 0, you can see x upon x is 1. If x less than 0, then it is minus 1. And if x equal to 0, then it is 0. Is that clear? Now it is very easy to say for x greater than 0, fx is what? 1. It's a constant function and you can say is continuous. Similar way, for x less than 0, fx is minus 1. So f is continuous. Because again you can say what? Constant function. Now in that case, we have to see the left hand limit and the right hand limit. So limit of x tends to 0 minus fx. Means limit of x tends to 0 minus fx is minus 1. So your answer is minus 1. Similar way, limit of x tends to 0 plus fx. You can say limit of x tends to 0 plus fx is 1 because x greater than 0, and that is 1. So here limit of left hand limit of the function is not equal to right hand limit of the function. So f is not continuous at x is equal to 0. Means function in this example, function is continuous for every point but discontinuous at x is equal to 0. We can say in this way. See, the next question is also simply like that. You can see sum number 9. fx is x upon modulus of x less than 0 is minus 1 x greater than or equal to 0. Now when x less than 0, mod of x is minus x. So x upon minus x. So fx becomes what? Minus 1 when x less than 0. Is equal to also minus 1 when x greater than 0. Equal to also minus 1 when x equal to 0. You can also see this way. So here again think for x less than 0, fx is minus 1. So f is continuous. For x greater than 0, fx is minus 1. So f is continuous. Understood? At this respective point, the function is continuous. But at that point only when we say what will be the thing. See, when you take the left hand limit of the function x tends to 0 minus fx, is you can say that limit of x tends to 0 minus means x less than 0, then it is minus 1 is minus 1. Similar way, limit of x tends to 0 plus fx means limit of x tends to 0 plus minus 1 is minus 1. So all the limits are equal, so we can say the limit of the function is continuous at x is equal to minus 1. Is that clear? See, the 10th is little bit different. See, fx is x plus 1, x is greater than or equal to 1, is x square plus 1, x is smaller than 1. We can simply write for x greater than 1, fx is x plus 1 is continuous. For x smaller than 1, fx is x square plus 1 is also continuous. Now we have to discuss the continuity for left hand limit and the right hand limit. So when I take limit of x tends to 1 minus fx, means limit of x tends to 1 minus. When x tends to 1 minus, x is smaller than 1, so you can use x square plus 1. So 1 plus 1 is 2. Limit of x tends to 1 plus fx means limit of x tends to 1 plus, means x greater than 1 means x plus 1. So it is also 2. And x is equal to 1, f1 is also 1 plus 1 is 2. So all the limits are equal, so you can say that a function is continuous. Let's see, limit of x tends to 1 minus fx is equal to limit of x tends to 1 plus fx is equal to f1. So therefore f is continuous. For every real number. So therefore f is continuous function. Is that clear? So this is about the continuity of the function at that real number. But see, now the next is little bit different. See, sum number 11. See, all the sums are quite similar one. X square minus 3, x is smaller than or equal to 2, is x square plus 1, x is greater than 2. First two statement easily you can make for x smaller than 2, fx is x square minus 3 is continuous function. For x greater than 2, fx is, it will be x square plus 1 is continuous function. Now we have to discuss the continuity at respective point, means at 2. So I just rough this simple same statement. हो गया. Now we have to discuss the continuity at x is equal to 2. See, it's very simple. Limit of x tends to 2 minus fx means limit of x tends to 2 minus, means x smaller than 2 is x square minus 3. So 4 minus 3 is plus 1. Limit of x tends to 2 plus fx means limit of x tends to 2 plus, means x greater than 2, then fx is x square plus 1. So 2 2s are 4 plus 1 is 5. So both the limits are different, means x tends to 2 minus fx is not equal to limit of x tends to 2 plus fx. See here, for less than 2 it is continuous, greater than 2 it is continuous, but at 2, at x is equal to 2, f is what? Discontinuous. Understood? So see, the rest of the sum is also quite similar one, so that you have to try. Okay, but I just take some different kind of sum कि some values we have to find out. जैसे कि Sum number 17 one, you can see fx is ax plus 1, x is smaller than or equal to 3, and bx plus 3, x is greater than 3. Here given that f is continuous at x is equal to 3, f is continuous at x is equal to 3, find the relation between a and b. So see here, f is continuous at x is equal to 3. We can say left hand limit and the right hand limit are the same. So x tends to 3 minus fx is equal to limit of x tends to 3 plus fx. Limit of, you can say limit of x tends to 3 minus, x tends to 3 minus means x less than 3. So it is what, ax plus 1 is equal to limit of x tends to 3 plus means what, fx is what, bx plus 3. See, either you take left limit or right hand limit. We have to take x is 3. So it will be what, 3a plus 1 is equal to 3b plus 3. So you can say 3a equal to 3b plus 2. So a equal to b plus 2 by 3. So this is the relation between a and b, you can say. Well, by using this, see here, by using this also we can find the value of the some unknown variable. See, I just take another sum related to this, that would be this one. See, 26 number. If the function is continuous, find the k. See, fx is k cos x upon pi minus 2x. X is not equal to pi by 2 and is equal to 3 when x is equal to pi by 2. If the function is continuous, f is continuous at x is equal to pi by 2, find k. Means if f is continuous at x is equal to pi by 2, limit of x tends to pi by 2, fx is what, f pi by 2. So we can say limit of x tends to pi by 2, fx means k cos x upon pi minus 2x is equal to f pi by 2 is 3. See, k is constant, so outside, sorry, k is constant, so outside, see, k is constant, so outside, k, limit of x tends to pi by 2. Cos x can we write sine pi by 2 minus x. If I take 2 common, so it is what, pi by 2 minus x is equal to 3. So this is k by 2. Limit of this sine theta upon theta is 1 is equal to 3. So k is equal to 6. So here you have to remember, some formulas of this limit. Because see, limit of x tends to pi by 2. X tends to pi by 2, so the pi by 2 minus x tends to 0. So you can say limit of theta tends to 0 or pi by 2 minus x tends to 0, sine pi by 2 minus x upon pi by 2 minus x. This limit of this function becomes 1. So k by 2 is 3. So k equal to 6. So like that, rest one is a very simple. Just you have to compare left hand limit and the right hand limit of the function, and you have to find out the value of unknown variable. Is that clear? Thank you very much. Hi, good morning students. In the last lecture we have seen about the continuous function, continuity of the function. when the function is continuous at any point. So say if limit of x tends to c fx is equal to fc, that function is called continuous. I repeat, limit of x tends to c fx is equal to fc, we say that the function is continuous at x is equal to c. Or another definition, left hand limit of the function x tends to c minus fx, or limit of x tends to c minus fx is equal to limit of x tends to c plus fx is equal to fc, then also that function is called continuous. Is that clear? So this is about the continuity of the function. Now the next thing is we see the sums related to this function. We have started first 6 sums. First 5 sums we have completed. Now the 6th one sum based on this only. Find all the points of a discontinuity of a where f is defined by your function fx is equal to 2x plus 3, x is greater than or equal to 2, and is equal to 2x minus 3, x is smaller than 2. Means when your function fx, means when your x is greater than or equal to 2, your fx is 2x plus 3 and x is smaller than 2. Oh, sorry, is there something wrong? Here, it should be less than or equal to, this should be greater than. So first we find the continuity for a greater than 2 and less than. So we directly can say fx is equal to 2x plus 3 is continuous at x smaller than 2. Even fx is equal to 2x minus 3 is continuous at x greater than 2. Means at that respective point your function is continuous. Now we have to discuss the continuity at x is equal to 2, and for that we take a left hand limit and a right hand limit. So limit of x tends to 2 minus fx. See, when you take x tends to 2 minus, x is smaller than 2. So that means limit of x tends to 2 minus fx is what? X smaller than 2. So say 2x plus 3. If I keep the value, so this 2 2s are 4 plus 3 is a 7. While when you keep the right hand limit of x tends to 2 plus fx. When you take x tends to 2 plus, means what? X is greater than 2, then the value will be of fx is 2x minus 3. So 2 2s are 4 minus 3 is 1. So here we can say limit of x tends to 2 minus fx is not equal to limit of x tends to 2 plus fx. So f is not continuous at x is equal to 2. It is very easily understand. The function is discontinuous at x is equal to 2. See, if I plot the graph, see, fx is again the another method for continuity of the function is through the graph 2x plus 3, x is smaller than or equal to 2 is 2x minus 3, x is greater than 2. Look, if I take a 2, it will be what? 2 2s are 4 plus 3 7. If I take a 1, so 2 plus 3 5. If I take 0, it is 3. If I take a 3, then we have to use this rule. So 3 2s are 6 minus 3 is 3. So when you plot a graph, of this function, see, it will be like this. I'm taking approximately the value. X is 0, then y will be 3. Samjho here it is 3. 1, then y is 5. 2, then y is 7. Barabar? But so your line ray will be going like this way when x is smaller than 2. But when 2, then it is 7. But 7 is not there. But after that 7, 3 is 3. 4 is then what? 3 is 3. 4 is that what? 4 2s are 8. 8 minus 3 is 5. So it will be going like this. So you can see here both the values are different. So that's why this function is not continuous. Is that clear? So here we have to discuss the continuity of the function. So we can say the function is discontinuous at that point which given. Similar way, 7th sum given, see, fx is equal to mod of x plus 3. X is smaller than or equal to minus 3 is equal to minus 2x when minus 3 less than x less than 3. And another one is 6x plus 2 x is greater than or equal to 3. See, when x is smaller than or equal to minus 3, your x is negative, so it should become 3 minus x. You can say the function. So here also we can write directly when fx is 3 minus x, f is continuous at x smaller than minus 3. I repeat, at x smaller than minus 3. When you take minus 3 to 3, fx is minus 2x. F is continuous at minus 3 less than x less than 3. Similar way, fx is equal to 6x plus 2. F is continuous at x is greater than 3. Greater than 3. So here your function fx when smaller than minus 3, between minus 3 and 3 and greater than 3, it is a continuous. You can write directly because even you can say that a polynomial function is continuous. But now we have to discuss the continuity of the function at minus 3 and 3. So first of all, I'm going for, I don't want to write again the question, so I just wrote this one. You understood this thing. Now please see. The next is, we have to check about the minus 3. So we take a limit of x tends to minus 3 minus left hand limit of the function. So we write limit of x tends to minus 3 minus. X tends to minus 3 minus means left hand limit of the function means your fx is 3 minus x. If I take minus 3, then it is what? 3 plus 3 is 6. Similar way, limit of x tends to minus 3 plus fx means limit of x tends to minus 3 plus, then x is greater than 3. So we use minus 2x. So it is what? Minus minus plus 6. So here this limit is similar. X tends to minus 3 minus fx is equal to limit of x tends to minus 3 plus fx. So we can say that f is continuous at x is equal to minus 3. See that respective intervals are there. There it is continuous. But now this function is continuous at x is equal to minus 3. Similar way, see, now we have to check the continuity at x is equal to plus 3. So we can say like this, see, we can say like this, limit of, again, x tends to, limit of x tends to 3 minus fx, means limit of x tends to 3 minus, this time fx you have to take means x smaller than 3, so minus 2x, but x is 3, so it is what? Minus 6. Similar way, limit of x tends to 3 plus fx, means limit of x tends to 3 plus, means right hand limit of the function means 6x plus 2. So 6 3s are 18 plus 2 is what? 20. These two are different, so we can say limit of x tends to 3 minus fx is not equal to limit of x tends to 3 plus fx. So function is not continuous. Function is not continuous at x is equal to 3. Means f is discontinuous at x is equal to 3. You can explain like this. See, my handwriting is not proper, but you understand, right? No problem. So understood. Here we have to discuss the continuity of related to the real number. Now